Now, one of the most important things, in my opinion, that people should learn is how to interpret data. Data is all around us. It's really the foundation of modern science. Without it, we wouldn't be able to do all the things that we do. And so I'm going to show you how to use GeoGebra to do some data analysis. Now, I want to say that the inspiration for this tutorial came from one of my favorite blogs about GeoGebra, and that's the Mathematics and Multimedia blog at math4, the number 4, allages.wordpress.com. It's a great tutorials on there. Great person who runs it, and you can find the link to his site on my site, brokenairplane.com. So you've opened up GeoGebra, and you're going to enable the spreadsheet by clicking on View and Spreadsheet. Now, I've already placed some data in here. This is data that I calculated out from the equations for free fall, if you drop an object in free fall on Earth. And so I have some velocity data, and I have the distance data, how far it falls each second and how fast it's getting each second after the acceleration due to gravity. But you could also just copy and paste in data or type in data that you get from any experiment. Now, you can graph data in Excel or something like that, but the great thing about GeoGebra is that it allows you to really play with that data, interpret it. It's not just a graphing software or graphing calculator. It has all these tools at your disposal that you can analyze the data and really just treat it as tangible data points as opposed to just putting it on the screen. So to plot these points, you're going to, let's highlight this column of data first, and you're going to right click it and create list of points, and you can see here that it's created these lists. So it's got these coordinate points stored in it based upon the points, the x and y, independent and dependent variables here. And then you can, if we zoom out, zoom out a bunch there, and then I can use the Move Graphics view. So maybe we'll zoom in a little bit more. Okay. So now that you get that data all centered, it's pretty simple to, from there, just analyze the data. We can go to this tool over here, the best fit line, and highlight the points, and boom, there's your data. There's your best fit line. Now, because I put these in, after calculating them, I knew it was going to be an exact fit, but it will still find the best fit for your data, even if it's not perfect. And if I right-click, just like we learned earlier, if I right-click this, I can change it into y equals mx plus b format, and you'll see that it's y equals 9.8 times x, which is the equation for a free-falling object. Acceleration times time gives you the velocity. And so here's the line for that. Now, for distance, it's not linear. It's not so simple. So what I'm going to do is not only show you how to create a best fit for that line, but or for that data, but also show you how to use the slider to create these polynomials, or to model different best fit lines. You'll see what I mean. So first thing you'll do is go to the input bar and type in n equals 1. We're going to create a slider where n is the order of the polynomial. And then we're going to turn on that slider, clicking there. And then I'm going to highlight the data for the distance. I'm actually going to turn off this data, just so that, I'm going to delete all this, just so that it isn't in our way anymore. There we go. And I'm going to highlight this data again, right click it, create a list of points, and then there are those points now. And because it's increasing much more rapidly, I have to shift the screen again a little bit. Alright, there we go. And now I can go down to the input bar and type in fit poly for fit polynomial, and then inside the brackets I'm going to put list 1 because that's the data I'm working with, and comma, n, because that's what I want it to be based upon, is what order of polynomial. And I don't just want it to be, a static number like, the first order or second order. I want to be able to use the slider to mess with it. And I'm going to close the bracket and hit enter. And now you can see the line, because it's set at 1. You see the straight line, but even from this, with this, you can see that it's not exactly the right fit for it. And so I'm going to first change the slider so that it only shows me the positive values here for my polynomial, and I'll make it up to 10 and increments of 1. Alright, so now when I change the slider, watch what happens. It changes, when I change it to squared, it's now a second degree polynomial, or exponential, quadratic, and then third degree, fourth degree, fifth degree, and sixth degree, and so on. Now it's still fitting the polynomial, so it's not, when it gets to these higher levels, it's not, fitting, so it's not really drawing anything. But if we look back here at the second degree polynomial, that definitely does fit our data. If you look here, you can see that it fits our data. And if we look at our equation, or our function that it creates because of that, 4.9 times x squared, that makes sense because the calculation for distance in free fall is 1/2 times the acceleration, 9.8, times time squared. So 4.9 times x squared fits perfectly. So this not only shows you how to graph the data, but it also shows you how to do a best fit, whether your line is linear or a higher level polynomial. So you can copy and paste in any kind of data you've got, and as much as you've got, and you can move, as you can see here, I can move the spreadsheet over as much space as you want, and really work with your students to create data. And you've still got all the GeoGebra tools here that you can work with that data. So data becomes a real thing. It becomes a real tangible thing. So thanks for watching, and I'll see you next time.